Hello and welcome to the TMC Newsroom. My name is Rich Tehrani. Thanks so much for watching us today. We're in San Jose this week, and on our program is Robert Day, who's a VP of Marketing at LynuxWorks. Hey, Robert, how are you?
I'm good, Rich. How are you?
Doing great. Thanks for being on our program.
No problem.
I was wondering if you could start off by telling us a little bit about your company.
Sure. LynuxWorks is we're a real-time embedded software company, and what we make are real-time operating systems. And a lot of what we focus on are basically high performance, high functionality, real-time systems. We've been very much in the communications world, so a lot of the telecommunication switches and data switches and things have been running our products. And more recently, we've been focusing on sort of the defense and the avionics market, which needs a lot of the performance, but also reliability that comes with our products.
Is the competitive set like a Wind River and QNX and those kinds of?
Yeah, I mean, they're our traditional competitors. We probably have some interesting differentiators over both of them.
Let's hit those.
Sure. Okie dokie.
Let me hear.
Okay. Yeah, so as far as LynuxWorks products are concerned, we've always been very much into open standards with high performance. So a bit like sort of Linux is now, but more performant, okay, but with a similar set of being able to run different applications on top of it. And we kind of conform to a lot of the POSIX standards, which is, you know, basically the Unix standard which is used in the embedded world. What we've been working on recently is actually moving into the world of secure operating systems. And in order to do that, we've actually designed a product from scratch, started it about 6 or 7 years ago, and it was designed basically for military defense systems. So it's a military-grade security system, or security operating system. And what this allows you to do is to basically run different applications in their own domains of security without having any ability to sort of to compromise the different domains.
Similar concept to virtualization.
Yeah, so it actually uses virtualization, but it's what we term secure virtualization. So you're right, what it does is it virtualizes or provides virtual machines that you can run your applications in, and these can run at different types or different levels or different security domains. Now, what we've also done with the product, which is called Link Secure, is we've built in a hypervisor. And what the hypervisor does, so we have the separation, which is part of the operating system, but we have the hypervisor that allows you to run multiple different operating systems, not just applications on top of it. So you could run a system that has a real-time operating system, a Linux operating system, and even a Windows operating system, all running on the same piece of physical hardware. And the security kernel, or the security operating system, essentially separates those domains from one another. But because it has the real-time and determinism that, you know, for example, a traditional hypervisor doesn't have, okay, you keep the performance in each of those domains while you're actually keeping the security between them too.
Now, at some point, you're going to have a challenge with performance just because you may have a challenge just because you may have more processing taking place and there is processing power. What happens at that point?
So, I mean, that's every software company's interesting issue. So what we do is we take advantage of a couple of interesting hardware features that are now available on a lot of the processors, you know, especially the Intel processors, for example. So Intel has a number of hardware virtualization that basically helps improve the performance of the software virtualization and hypervisor that run on top of it. The other key thing is multi-core. So what we're seeing now is that you're taking traditionally separate single-core systems and bringing them onto a single multi-core system. And what our Link Secure product does is allow you to allocate the time that you want each of these domains or the cores that you want each of these domains to run on. So in let's say a 4-core system, we could have one operating system, one virtualized operating system that's running symmetric multiprocessing across 2 of the cores. So if you want that one to have, you know, the real kicking performance, then you run on 2 cores and have SMP. Then you could have another operating system that, let's say, we dedicate a core to, which is often good for running Windows, because Windows is sort of assuming it's got its own core anyway. And then you can have another set of operating systems that maybe don't need to have all of the performance of one core, so they could share a core.
Sure.
And that's all done within the Lynx Secure product.
That's great. So what are you seeing from your customer base? So you have a diverse customer base between government and the commercial sector. Are trends that you're seeing?
Right, okay. So the government sector, likes this technology because of the security. There's the consolidation of physical devices, which they've had used for security, into a single device, but with the software security, the software domains in there. What we're seeing in the commercial world is a similar thing. They don't necessarily need the same level of security that you have in a military system, but this whole ability to run multiple different operating systems and applications on the same system without without worrying about one contaminating the other or without one spoiling the performance of the other. So this whole thought of having a real-time system and a Windows system, for example, which have traditionally been two boxes. Your real-time system, which communicates with the real-time world, has been a separate device, and then you network it to a PC. Well, now you could stick all of that in one box, and you run it in its own virtual container.
So if I'm just understanding this correctly, there's a potential trend for some applications to potentially choose your systems as opposed to maybe a Citrix system or a VMware system, right? Because they're getting an added benefit of security and real-time features that they weren't able to get with these traditionally with these systems.
Yeah, so the traditional hypervisors, like the ones you mentioned, they haven't been built with security in mind. They have an inherent security because they're virtualized.
Sure.
But then they weren't designed for security, whereas ours was. Plus, they weren't designed for real-time.
Sure.
So we put both real-time determinism and security in the same box. Yeah, it could be a very viable alternative.
Well, at least, I'm sorry to cut you off there, but it's kind of exciting because some things are clicking in my head. One of the other guests we had recently was ShoreTel on the program yesterday, and ShoreTel is virtualizing their servers, and I know Mitel and some of the other communications companies are virtualizing their communication servers. And so subsequently a real-time system where you can put communications it suddenly makes more sense when you have these sorts of mission-critical real-time apps that are going virtualized. Now you can really kind of ensure their performance.
Yeah, I mean, I hadn't thought of it this way, but it's sort of like a real-time virtual appliance.
Exactly.
And so people are doing virtual appliances, running on top of Windows. This doesn't run on top of Windows.
Right.
This is a bare metal hypervisor. So this thing screams if you need it to, as far as screams as performance-wise.
Sure.
Plus
just to tell the audience, that doesn't mean it's loud.
Well, it could be if you wanted to.
If they've made it through this far, they're with us.
Yeah, I guess. Maybe I should be more careful with the words, but whatever.
It runs extremely quickly.
It runs very fast.
Okay.
And
don't say it runs hot.
No, it doesn't run hot. We're not going to go there either. But yeah, so you keep that real-time performance and determinism, even if on the same system you're running an operating system like Windows, which is not necessarily known for its real-time performance and determinism. So you get the user interface that people want and are used to without sacrificing or compromising the performance that they need for the embedded side. Well, so it's kind of fun.
Yeah, really, it sounds like it. Thanks for being on the program, and hopefully we'll have you back again soon. You'll tell us about your progress.
Rich, thank you so much. All right.